It's 1 now, -1. But I don't want you to know any of that. This is one of the reasons this sheet has to be macro enabled, because there's a very little macro that looks what's changed. And if it's one of those cells, it does a certain thing. All it does is if the value is 1, makes it -1. If it's -1, makes it 1. That's all it does. But there are ways you can run macros based on change or based on something double clicked. If I double click anywhere else other than those, nothing will happen. You will actually get double click opens up the cell to enter stuff. But if I double click on these, those options may have 3 values, on, off, in between. Certain problems, the formula depends upon what those options are. That's why I allowed options. Again, I left 3 in here for you to see, different icons. Green may mean something else to you. Yellow and red also may mean something else. If you want, we can even do those up to 5 icons, but well, we're not going to worry about that. Typically, you don't need that kind of options, but I'll show you how to do it in general. All right, I set up the problem. Basically, if I enter the inputs, it's going to calculate me the future value. Okay, that's my left-hand side formula. Now, when I go to solver mode, given the target value, it's going to find me the value of the unknown, which I picked to be present value. That actually makes the difference between left-hand side and right-hand side 0. Okay. I mean, in this case, it's already 0. So if I enter target, right now it's not 0 anymore. Okay. So let's make it into solver mode. Done. It's a simple problem, so it doesn't take Excel to solve it. Now you're saying, okay, I need to invest $211.11. If I invest that and I could earn 25% on it every year for 15 cents, that's going to be 6 grand. Nice. But what if the interest rate is different? At 10%, that's a different number. I mean, the appearance of it, it's as if I actually have a formula in there that immediately changes. Since this is a simple problem, finding the solution is not that complicated. There's actually an iterative procedure underneath. Technically speaking, Excel basically defines a bracket where the solution lies, which means 2 values, one for which the difference is negative, another for which the difference is positive. If the function is continuous, you know the solution exists somewhere between the two, then you basically have that, you bisect, you hunt it like a scared little rabbit, okay? But Excel that's in the background for you anyway. It's the same thing if you were using the solver. In fact, underneath I am using solver. You just don't see that part. And I will show you, not necessarily this week, but next week, how to actually make solver to do that. That's why I have this cell and we're going to talk about named ranges too. Solver pick is the name of that cell for where you determine the name, determine the variable for which to solve, and drop list, that's the list of those variables. It says go find a match, and basically once you find the match, add 3 rows to the row and go to the fourth column and get me that address, because I have to feed that into solver underneath. And when you use solver, you say by changing what? I'm going to tell solver by changing D5. As I change the variable, automatically it's going to change its color. For example, if I switch to interest rate, I know I'm changing for that. That's again, I'm not using conditional formatting for that, but something similar. And because you have to tell what you want to call solver three things. What's your target? Technically speaking, that's my target cell. I want to make that 0. Since I'm doing the difference between left and right, I don't have to worry about the value of the target, but I want that target to be 0, and I want that to be achieved by changing the cell D6. Had I done the solver manually, I would have had to provide those myself. All this does, it makes the solver user-friendly for you. There is nothing here that you could not have done by yourself. It just makes it easier. And it definitely is much prettier than the solver dialog box. And I'm not a guy whose aesthetics is not that high, but this doesn't look too bad. And, colors also mean something. Those pink, that's my approximation to red, because red cells don't show very well in these screens. You have red light, you don't touch them. Okay. The greens are things that you have the green light to change. So suppose I want to ask the following question. I'm going to invest $2,000. Okay. It automatically, makes the solution. I'm going to invest $2,000 for 25 periods. At what interest rate that would become $6,000? Turns out it's 449. Okay. If I want $10,000 instead, it's 665. Again, the equation for that is simple. We can solve for that R rather easily. In this case, R would be, let me see. This should be FV, by the way. PV over FVT raised to the power 1 over T minus 1. Again, it's not complicated, but why open yourself up to make a formula mistake? We're human, we make mistakes. I've been using Excel ever since there were no mice for Microsoft PCs. In fact, there was no Windows, you had DOS. The mice came after Windows 3.1 came along. I've been using Excel since 1984-85. I'm a surgeon with it, and I make formula mistakes. Why? As I get older, I'm more likely to make mistakes. Plus, your level of attention is not the same in the morning versus in the evening, or you're bothered by something at home. When you do work, it doesn't matter what sort of work, to the extent possible, you should eliminate the human component if you can. In this case, I can. All I have to do, I don't have to worry about that complicated formula. All I have to do is do the simple formula. But even that formula, I don't have to do. There's an easier way to make that calculation. Excel has a built-in function called FV, F for future, V for V. In fact, it even does similar calculations where there are periodic payments as well, which we're going to do. I mean, not today, but on Wednesday. On Wednesday, we're going to actually take this sheet. We're going to ask the following question. We're going to set up the following screen. I'm going to start saving with a certain amount, let's say $10,000. Over the next 40 years, every month, I'm going to save some more, but I'm going to start with, let's say, $100. But every year, that $100 is going to increase by 3%. You know, I get raises and stuff. And I'm going to basically prorate that growth into months. I'm going to do this for 40 years. And the balance of my account is going to earn 8% on an APR basis, or 0.75. No, 8 would be 0.666% every month. How much money will I have 40 years from now? The growing part is not built into Excel, but we're going to build our own function that calculates the value of a growing annuity, future value, and we're going to do something like that for present value. And if I ask you the following question, I want to have $5 million in my account, I could earn 3% or 8% on an APR basis while I'm saving. I'm going to start with $10,000, and the growth rate of my monthly additional savings is going to be 5%. What is my first month savings?